There are a few carbohydrates that you will be expected to identify, and one of them is sucrose. Sucrose is a disaccharide made from the bonding of glucose, which is a monomer, and fructose, which is another monomer. Now, fructose has the exact same chemical formula as glucose, C6H12O6. However, the connections and bonding are slightly different. Now, this graphic on the slide comes from your textbook. I feel like it's a little confusing, so we're going to look at this slide, which also has some mistakes, but they're not as confusing, I think, as the other slide. All right, so sucrose forms between glucose and fructose, and it is always between alpha glucose and beta fructose. So let's look at glucose. We've already seen that alpha is defined when the hydroxyl on the C1 is below the plane. And all the carbons in this ring structure for glucose are numbered. Carbon 1 is the only carbon in the ring that is bonded to two oxygens, and the hydrogens are not expressly written. So each carbon in the ring also has a hydrogen, and it'll just be above or below the plane depending on whether the hydroxyl or carbon is above or below the plane. All right, now let's take a look at fructose. So when fructose dissolves in water, it actually forms a five-membered ring, which, like glucose, contains an oxygen. But let's look at the numbering, and this is where the mistake on this slide is. This one up here on that hydroxyl should actually be down here with the CH2OH. This down here is the carbon 1 in fructose, and carbon 2 is this carbon, which is on the far right-hand angle, in the same place where carbon 1 is for glucose. So carbon 2 in fructose is similar to carbon 1 in glucose in that it is the only carbon in the ring that is bonded to two oxygen, the oxygen in the hydroxyl group above it and the oxygen in the ring. Now, like glucose, fructose can be alpha or beta depending on whether this hydroxyl that is bonded to the C2 is above the plane, that's beta, or below the plane, and that is alpha. So when sucrose is formed, it is always formed from alpha glucose, where the C1 in glucose has the hydroxyl below the plane. And it always forms with beta fructose, where the hydroxyl bonded to the C2 is above the plane. So a condensation reaction occurs where water is released and a bond occurs between the C1 of glucose and the C2 of fructose. And it's basically an ether linkage. It's also known as alpha beta 1,2 or alpha 1 beta 2 glycosidic. Glycosidic just means it's a bond between two sugar molecules. So in the glucose, we see that the bond that connects it to the fructose, this ether connection, this oxygen in the ether is below the plane, so it remains alpha, and the oxygen in this ether linkage between glucose and fructose is above the plane of fructose, so it remains beta. So while these glucose and fructose are monomers, the C1 in glucose and the C2 in fructose can switch between the alpha and beta form just in solution. But once sucrose forms, then this alpha-beta relationship of the oxygen to the two planes of each molecule is static. It doesn't change.